It's Halloween, and I trick-or-treat at my great-grandma's nursing home. I normally get a variety of candy, but I really like circus peanuts. I usually get them 33% of the time, and I usually get other candies about 67% of the time. But if I'm lucky, I'll get some circus peanuts when I go trick-or-treating to all my great-grandma's friends, because I think I have a better chance of getting circus peanuts there than anywhere else. Sometimes I'll get some other kinds of candy like Sour Patch Kids or Reese's, but who wants those? If I get lucky, I'll get circus peanuts. One time, I actually got 5 circus peanuts in a row. I was super excited because circus peanuts are my favorite, and I got 5 times in a row. I'm pretty sure that more people have adopted my love of circus peanuts. I don't know, it could just be random chance. Well, how can we figure out whether or not 5 in a row is enough to suggest that more people are giving out circus peanuts than the usual 33% or not? Well, we could run a simulation, and a simulation is an imitation of chance behavior. There are 4 main steps to successfully running a simulation. You can remember the steps, which are laid out with SPDC, with the acronym Standard Peanuts Do Crunch. The S in standard represents state, which you restate the question and form a hypothesis. Then the P, or peanuts, represents plan, which is where you plan what you want your simulation to be. And then the D is do, which is still do, and that's where you actually run your simulation. And then the C is conclude, which is where you figure out what your results are and what they want. So the question that we are asking in our simulation is, are more people giving out more circus peanuts than normal based off of the 5 in a row? Our assumption is that it's most likely just random chance, because we feel like the probability of getting 5 in a row is not that outlandish. And usually it's a 3 in 1 or 33% chance of getting circus peanuts, which is independent from getting any other kind of candy. So we want to see in our simulation if this increases or decreases. So next we're going to plan our simulation. So first we want to figure out whether we want to use a dice, a digitable, or a calculator to run our simulation. We're going to use a dice, so we're going to assign numbers on our dice. We have 6 numbers to choose from, and 1 or 2 are going to be circus peanuts, 3 through 6 are other candies, because 2 out of 6 numbers is 33%, which follows our simulation. So then we're going to run this simulation 20 times and tally the results, because repetition is super important to make the quality of your simulation results the most accurate and the best that they can be. So then after this, you actually run your simulation. So then we have our results, and as you can see in the table, in our simulation we got peanuts 5 times in a row, 5 times, and didn't get peanuts 5 times in a row 15 times out of 20. This means that 5 times out of 20, or about 25% of the time, peanuts are usually 5 times in a row. Because of the simulation getting 5 peanuts in a row occurring 25% of the time, when there is an expected probability of getting circus peanuts about 33%, which is what I observe normally, it can be assumed that getting circus peanuts 5 times in a row is not rare, and it actually means that the same amount of circus peanuts was given out this year.